All right, went and got myself a Libro. The first question, oops, my pen just fell. The first question, the wildebeest saves the day. What the hell? I'll read it. Long-term records from the Serengeti National Park in Tanzania show interesting ecological relationships. When wildebeest are more abundant, they graze the grass more heavily, so there are fewer fires. Researchers collected data on one part of the cycle and compared a least squares regression line, so they made a y hat equals a plus bx line, relating y as the percent of grass area burned to x the wildebeest abundance in thousands. So more wildebeest, we should see less fires. That's what they're saying. That should be a negative slope in our actual scatter plot. In the same year, here's a residual plot for the model. So the wildebeest is the x, but they didn't give us wildfires. They gave us the residuals, and our job is to decide if the line was a good idea in the first place. Read part A. Use the residual plot to determine whether the regression model is appropriate. That means, was it a good idea to put a line through the scatter plot, or should it have been curved? So I look, I see positives, I see negatives, and I don't see a regular pattern. And so my answer is going to be that the line was a good fit because the residual plot does have uniform scatter. Okay? Then part B says, interpret the value. They give us a value for S. So I'm just going to write it up here, 15.99. And the R squared is 0.646. So I'm going to go down to C and write R squared is 0.646. And then I don't need the book anymore. We can just interpret our answers. Let me make sure you can see what's going on here. Okay, 15.99 is the standard deviation of the residuals. That's what S is going to be for us every time. Okay, the interpretation, here we go. When using the LSRL, that's least squares regression line, and of course, by that, I mean y equals a plus bx, right? I mean that least squares regression line. When using that to make predictions, basically when I put the line through the middle of the scatter plot and I see where the dots are compared to where the line is, this is what's true. We are off by an average of 15.99. And I should put units there for whatever the Y value units, for the fires or whatever, but I don't know what that unit was. So I don't know if it's fires or acres of fire. So I'm just going to leave it alone. Then part C, R squared is 0.646. This is that really weird one. Okay, in the first place, I'm going to call it what it is. It's the coefficient. It's the coefficient of determination. I don't know how well I spelled coefficient there. There should be an I after the C and before the E. That's just straight up ugly right there. But anyway, here's your interpretation. Just write it word for word every time, okay? 64.6% of the variation. Now in the definition it said of the Y variable, right? But this should be about percent of grass burnt. I think it's something like that. I closed the book, but it had something to do with grass burnt. So 64.6% of the variation, I'm just going to put in grass burnt, is explained by the least squares regression line, so I'll put LSRL again, of grass burnt. That's the name of the variable, okay? So it's like saying Y on wildebeest abundance. And I'm writing that just because that's the name of the X variable. So I put it in quotes, wildebeest abundance, and it goes X. It's always going to go Y on X. That's the direction of that phrase. And if we have words to use, we use the word on the word. See what I mean? Okay, your homework is on page 156 through 158. I want you to do 1 through 4, and 7, and 11, and 14 today. You've been a great crowd. Have a great day.